solutions have traditionally been seen as a technology more suitable for residential applications. However, it seems times are changing. One hybrid solution in particular caught our attention because of its potential to decarbonize heat in a commercial and industrial space, and it's taking a mature technology like solar to the next level. The technology in question has been designed by British engineering scale-up Naked Energy. It produces electricity and heat at the same time and can convert nearly 80% of the sun's energy into usable energy from a single roof space. It's the only solar tech that produces electricity and hot water within an evacuated tube, a solution that certainly looks very unique when deployed on a rooftop. I spoke to Naked Energy CEO Christophe Williams to learn more about the applications for this technology and why it's attracting the attention of the likes of the British Library. I'm Pamela Largue, and this is the Energy Transitions Podcast. Christophe, thank you so much for joining me today. Before we start talking about technology and market insights, tell us a little bit about Naked Energy, what it is that you do, and how you came upon this name for the company.
That's a great question. Naked Energy is really interesting. I get asked that quite a lot because when you go to events and you say, well, from Naked Energy, it raises an eyebrow, that's for sure. And people remember the company. When I started the company, I think ultimately the industry is quite boring. There was a lot of companies like Solar One or One This, or it was quite corporate and boring. And I knew we needed a name that kind of would stand out and be remembered. But also, we wanted a name that kind of represented what we're about, which is about peeling back the layers. It's about raw energy. It's about the opposite of fossil fuels. It's clean, it's pure, it's transparent. We're just being very honest about the energy we generate, how we generate it, how we make our products, and the problem that we're trying to solve. And also, we wanted to keep it technology agnostic. When we started the company, we were looking at solar, wind, and marine technology. And so we have different options, and we decided to really double down and focus just on solar. And so we didn't want to give it a technology name in the company name, just keep it all about generating really cool IP and really nice product and keep it design focused. So that's where Naked came from. It was pure, clean energy.
When I was doing some research into Naked Energy, something that really struck me was you say that you're redefining solar. Now, solar is a really mature technology, so I think I'd like to touch on that a little bit. How do you redefine a technology that is so mature? Tell us about that.
Yeah, I think if I say the word solar energy to nearly anybody, they'll think of a PV panel, the typical one you see on a family home or something like that, or the modules that are manufactured in the Far East. That's what I think has become ubiquitous. It's like a commodity now. Many billions and billions of pounds have been spent on advancing solar energy and the supply chain, and even some governments supporting and putting huge stimulus funds into the local industry so they could make a negative gross margin and get market share. So you're right, it's a very mature technology. Even the silicon cells that are developed that are the heart of the solar panel, the bit that converts the sunlight into electricity. That was originally designed to go on satellites so that you could generate power in completely remote locations where there's no grid. But that's got better and better and more efficient. And so those solar panels just produce electricity, which is great. We need clean power. And so it's the fastest growing source of renewable power in the world alongside wind. So it's great. We need renewable power, but we also need renewable energy. And this is an important distinction because I think in a lot of commentary, when people talk about the energy transition, they focus a lot about electricity, where actually heat is 3 times bigger, heat demand globally is 3 times bigger than total power demand in the world. And 90% of that heat demand still comes from fossil fuels, which in turn delivers and produces 40% of all the emissions that we emit on the planet. So it's a massive, massive challenge. And unless we decarbonize heat, we're never going to get to net zero, let alone carbon zero. So when we look at solar, we've developed a technology that produces not just electricity, but it also produces heat at the same time. So we're taking a technology that's around about 18 to 20% efficient, some of the really, really efficient ones, to a technology that can nearly convert 80% of the sun's energy into usable energy from a roof space. So it's from one source of energy, the sun, we're producing heat and power around about 20% efficient electricity and 60% hot water. That's a combined efficiency, which means you're getting a lot more energy from your roof space, and it's hybridization, and we've done it in a very unique way. It's the only solar technology in the world where we've produced electricity, hot water within an evacuated tube. And the evacuated tube, what that does is it means that if it's cold outside or if it's windy, the warmth from the sun, when it comes into the tube, it's like a thermos flask. You know, when you put hot water in your thermos flask, it stays hot for a long, long time because it traps the heat. And that's what our tubes do. It traps the heat from the sun. It's like a greenhouse. And that means that we can use that warmth inside the building or the application that you're using. And typically that's for hot water in commercial and industrial buildings, and the electricity is used on site as well. So we think we're redefining solar energy by the design, the increased energy density, we call that. So where you produce more energy in less space, we call that energy density. And the way it's elegant, it's low profile, it's modular, and so it's one design, it's one trip to the roof, it's one set of installers, and we're redefining solar not just with the hardware, but also with the digital assets that we've generated. So we have a really unique monitoring platform that can measure the systems, can see exactly how much heat and power is being generated. It looks at all the key vital statistics of a project. It can do financial, carbon reporting, and it can get smarter as these systems learn about usage profiles and things like that, and weather patterns. It gets smarter. And we've also developed some design tools as well, so we can get the technology implemented onto roofs and digitizing that process. So we're kind of redefining how it works, we're redefining how it's integrated, and we're redefining kind of how it's monitored as well and measured on buildings. And we also have a sister product called Virtue Hot. I should have said the product range is called Virtue. Virtue PVT is our kind of flagship product, the one that produces heat and power. But we have a beautiful solar thermal technology called Virtue Hot, which gets hotter, goes to higher temperatures. And that's a pure thermal product. It looks exactly the same, except it doesn't have the PV cells inside. And that delivers really efficient hot water up to 120 degrees Celsius for commercial and industrial buildings as well. And we've been doing quite a few exciting projects recently as well. So that's how we think we're redefining solar and trying to decarbonize heat, which is a key thing as well that we're focused on.
I'm really pleased that you mentioned the decarbonizing heat aspect. It's a really great segue into my next question, because that is a really important topic that we need to delve into. Why is decarbonizing heat such a critical topic for our energy transition right now?
It's a critical topic for some of the points I just mentioned. I mean, one, its size. I think it's like 212 exajoules of energy, which doesn't mean anything to anybody. That's just, many tens of thousands of terawatt hours of energy demand, and that's hot water in buildings, in homes, and commercial and industrial buildings. It's process heat in industry, and it's heat to do air conditioning as well. It's a huge total energy demand. So the absolute demand is massive. It's primarily massively driven by or supplied by fossil fuels at the moment. And so it's massively polluting and it needs to be decarbonized. So, we have to address this sector, but it's tough, right? So the reason why, we call it the kind of the cold or the warm elephant in the room, depending on how you want to address, the heat demand. But it's been left in the too hard box for too long. And the reason being is that decarbonizing electricity is very challenging as well, because our grids are very, very old and not used to renewable and variable power coming onto the grid. But it's slightly easier. So putting up wind farms, solar farms, things like that is easier than decarbonizing heat, because heat essentially is gas boilers, big industrial furnaces. It's a distributed type of energy. So you generate heat where you need it in buildings or in industry. And so that is hard to decarbonize because you need to generate the heat where it's needed. And this is why we really, really think that distributed energy like solar thermal, combined with heat pumps and other electric boilers and other energy efficiency measures, is so vital, because you generate the heat where it's needed rather than putting it into a central power station and distributing it through pipes or cables throughout the countryside. It's generate it where you need it. And so that's why I think it's been left in the too hard box for too long. And so the main strategy for decarbonizing heat is electrification. And that is through primarily, say, heat pumps. And heat pumps are a fantastic technology. You put 1 unit of electricity into it, you get about 2 to 3 units of heat, which is really, really good. So long as the electricity going in is clean, it's renewable power, which is really important because our grids aren't 100% renewable yet, and they won't be for a little while. But also, like we said, heat demand is 3 times greater than power demand. And so if we electrify all our heat demand, and then we also start electrifying transport, which we're doing now with EVs, where is all this renewable power going to come from? And even if we could generate all this renewable power, how are we going to get it to all these end customers sustainably, affordably, reliably? It becomes a really big challenge. And so we will electrify heat. It will take more time. It will come at a cost, or investment, as I like to put it. This is all an investment. There is an ROI for the energy transition. But what often gets overlooked is important technologies like solar thermal, like geothermal, where you can take this renewable heat source and combine it with heat pumps and other electrification technologies. So it's a huge energy vector that needs to be decarbonized, but it's been left alone because it is very tough. It's challenging to do. So maybe it's focused on power first, and now the elephant is definitely making some more noise.
Christophe, it seems very clear why a solution such as a hybridized solar and thermal solution would be required. Tell us more about the specific use cases or the sectors or industries that would be looking to a solution like this, where you believe this will have the biggest impact.
Yeah, so I think before I sort of focus on the specific sectors, I think what's really important is to have a bit of a backdrop as to the solar thermal industry in the past, because historically it's been seen as a hobbyist technology, maybe for a single family home where they want to install the technology themselves, because actually the energy demand in your building, your home, and in commercial industrial buildings is typically 3 times more heat than electricity. So the energy you need is actually heat energy. But solar thermal has been seen very much as a residential single family home technology, whereas there is a big opportunity in the commercial and industrial, sort of lower temperatures. This is from 20 degrees Celsius all the way up to, say, 200 degrees Celsius. This is a temperature range that can be addressed by solar thermal and combined heat and power solar. And so Naked Energy, we've focused on the commercial and industrial sector because the specific demand is bigger. So the actual heat use is bigger. And vitally, we focus on commercial and industrial clients that need heat all year round. They need it in the summer. Because if you think about your distribution curve, you have more solar energy in the summer than you do in the winter. And so typically, obviously, if you're in the Northern Hemisphere, that's the case. But you get a greater distribution in the summer. And so what you don't want to do is you don't want to be oversupplying energy to that end customer because the technology is very efficient. You're converting between 60 to 80% of the sun's heat into hot water. It's really, really efficient. And so we typically size the solution to deliver 90% of a customer's hot water demand and heat demand in the summer. And these are customers like hotels. So we've done a lot of projects. I've done projects now with, and the press release actually just came out today for the Mandarin Oriental Hyde Park Corner. It's a really exciting project. We've done an installation with NH Hotels. We're currently installing with IHG Hotels as well in Malta. And these are customers that need hot water every day, hundreds of cubic meters of hot water every day at the peak of summer. So they're a great fit to solar thermal technology. Other typical customers are, say, hospitals. They're the whole healthcare industry. They need a lot of sanitary hot water every day for cleaning, sanitization, sterilization, things like that, and catering as well. The food and beverage industry is a huge industry that needs heat every day, all year round, and that's for cleaning in place, sanitization, sterilization, things like that as well. So, and even the textiles industry. And so these are huge heat users. And typically these customers have limited roof space. The big sort of limiting factor for them to get off gas and become more energy independent is, well, how big is my roof? And if you put PV down, it's a great technology, but electricity is a really high value energy, right? Don't use electricity to then create heat. Use it for other appliances that you've got. So with the higher efficiency of solar thermal, use that for hot water. And hot water takes a lot of energy to warm up, and it has the highest specific heat capacity of any common substance on the planet. So it takes a lot of energy to warm water. So use solar thermal. And our philosophy is a lot of these clients, if they've got a very limited roof space, then get heat and power from your roof. And that's where the hybridization, the combined heat and power solution is really attractive. And particularly if some of these clients have visual impact issues, they don't want to have panels sticking up because our tubes are very low profile. They're only 26 centimeters actually off the roof line when they're installed. It means you get less wind shear resistance on the building as well. So some are these customers are very architecturally sensitive. They want to make sure their building doesn't look higgledy-piggledy, and they want a nice uniform look. So getting heat and power from the limited roof space is really valuable, and making sure it's done in a very elegant and technically efficient way as well is really important. So yeah, those are the sectors and kind of why they want heat and power from the building.
One building that I would assume is architecturally sensitive, as you say, is the British Library. And if I'm not mistaken, this is one of the projects, one of your flagship projects, actually, if I'm correct. Tell us a little bit more about that, Christophe, because it's quite interesting.
It's definitely interesting, and it's definitely our flagship. It's our biggest project to date. We're actually in construction with a project that's twice the size of the British Library, and it's in Coventry. That will be public, we hope, in a few months' time, and so that's a really exciting project. But the British Library project was nearly 0.5 megawatt of our product on one roof, which is really exciting. And we understand it to be the biggest solar heat project ever in the UK. And it's really interesting for so many reasons. I mean, one, it's just an iconic institution. I mean, our national archives are there, and it's just phenomenal. Some of the literature and incredible folios they have in the library, and it's a center of knowledge, right? It's a public building, but you go there to learn, and so it's an amazing building, an amazing institution, and we work with CBRE to develop the project. and our local our installers called Convert Energy were really instrumental in helping design and integrate our solution. Because ultimately, Naked Energy, we're the technology owners. We're not actually installers, but we support our installers in terms of how to develop projects. And so we kind of thought, it's a library. Why do they need all that hot water? What's how unusual? It's not your typical use case. And when you then look at the data, you go, wow, there's actually a huge gas consumption. And the British Library itself is on like 9 floors, and the plant room itself is almost the size of a football field down below. It's extraordinary, and I think you can hear the underground running underneath. It goes really low down. And when you look at it, they need a lot of hot water for the public toilets. There's a lot of washing hands and cleaning, the staff as well, and there's catering, and there's a lot of heat needed for the low temperature heating of the building. So in the shoulder seasons and winter, obviously, there's a big heating demand. But one really interesting area for the heat demand was actually for dehumidification. And this is something quite novel and quite interesting. So the heat we generate goes into two circuits. One is for the hot water I just mentioned, for public toilets and heating, and the other goes towards a heat dehumidification process through it's a silica gel process, where they have a special archive of books like the Magna Carta, Shakespeare's First Folio. I mean, it's extraordinary, but they have to keep the moisture in those chambers exactly the right moisture, and they control that moisture level by temperature. So these silica gels, depending on their temperature, they either release or absorb moisture. And so the heat that we generate from our array helps control that humidity process. So very clever, really, really exciting. And to think that the product on the roof is helping protect some of those precious manuscripts is really quite extraordinary. So it's an amazing project on many levels, and it's been operating now for over a year and a half, and just incredible. Every time I drive past, I'm still pinching myself that our technology is up there. It's just incredible.
I love that to actually have a real world example, and one that's really special and unique. I think it's great, and like you say, your technology is sitting on the roof doing its thing and helping to protect that knowledge.
Another coupling, or an important part, obviously, is the energy within the building, but also I just wanted to add that the array itself saves 70 tons of carbon that would have been emitted by burning gas to generate that energy. So it's generating over 30 megawatt hours of energy per annum. So it's there, it's installed, and it will last for more than 20 years at least. So 70 tons of carbon a year is being abated just by having the array on the roof. So that's an important decarbonisation aspect. We talked about decarbonising heat, and yeah, it's so nice to have that and see it working and saving carbon.
Absolutely. And I think what really struck me when I was looking at the images of the technology, it's very unique. Just the way the solar array is designed, it's very different to what I'm used to seeing, the flat panels. So does that increase efficiency? Tell us about this unique design.
Yeah, I guess that goes back to the redefining solar, right? So, and I really don't like the word panel. It feels very flat and very bland. So, they're definitely not solar panels. They're cylindrical. We call them collectors or modules. Yeah, and I guess it's interesting because I'm not an engineer. I'm not a scientist. I'm my family. There's a lineage of scientists in my family. So my grandfather and even my daughter, she's a scientist, and it's just extraordinary. But yeah, my name's on the patent because I come from a creative background, a design background, and the other two names were inventors who were in solar thermal and engineers. And I guess I came from a slightly different angle and think outside the tube, and so looked at the designs and went, hang on, can't we hybridize this? Doesn't it make more sense? And then so it came from very much a sort of design background, and I don't think any sane engineer probably would have come up with this concept of hybridizing in a vacuum, water and electricity, because it is complicated. It's taken time to develop. We've got over 26 patents. We own all our own IP. It's taken time to go from a drawing to proving, raising money and getting it onto buildings like the British Library and developing the supply chain and partners. So it takes time to do it. So yeah, it's a very unique design in terms of the tubes themselves, how they're integrated, how they're constructed, and we're taking kind of mature technologies, but we're putting it together in a very unique way. And there's another aspect as well that between the tubes, we have this reflector. We call it a reflector, which is really interesting because normal solar panels, you need to angle them to the sun to be able to get good output. But when you angle it to the sun, it creates a shadow, particularly in the shoulder season and the winter season. So you need to put the other panel quite a little distance away from it, because if it shades that panel's shaded output is what limits its output. So it only delivers the energy of the shaded cells. So you lose a lot of efficiency effectively. So we thought, well, hang on, we don't want to waste that space. So we put a reflective element that then when the sun is high in the sky in the summer, those gaps are generating energy. We're bouncing that light in and we get about 15% more energy throughout the year by integrating that technology. So that's something that's quite unique in our design as well. It's like a low level concentrator, which sits in between the tubes. We have a design without the reflector for lower latitude countries where the sun is typically higher in the sky. We then have a tighter pitch on the tube, so you get a higher peak capacity, and you don't need the reflector as much. So yeah, it's a combination of that, and also the racking system we've designed, whether it's a flat roof, vertical facade, or pitched roof. Our racking system integrates into those buildings, and the tubes are all modular, and there's no margin for error. You get the right angle on the absorbers and things like that. So we spent a lot of time designing the product to be optimal for different latitudes, different buildings, different types of installations and customers. So yeah, it looks very different, which is part of the whole aesthetic of Virtue.
Did you always know that you wanted to work in the renewable energy space, Christophe? You say you're not an engineer, but what was your ideal career, perhaps should I say, or did you always want to be in this space?
No, it's funny because I talk to youngsters now and really young kids, and I've got two daughters that are growing, getting through university, and going out in the world and doing incredible things. And some of them going, I've got to decide already, what I'm going to do for a career. And in a way, it's like just see how you go, see how you get on. And I was a bit like that. I was very lucky. My parents sent me to some really good schools. I was okay academically. I wasn't amazing. I was okay. I went down the creative path. I was very arty at school and really liked painting and sculpture and photography and film. And so yeah, I went to art college, St. Martin's Art College, and did a foundation and just did loads of different stuff, which I loved. But I got a lucky break in the film business, working in a film editing company, and I just got the bug. I thought this is amazing, and it's all very digital. Well, it wasn't then; it was very analog. We were working on film, so I was a runner, a T-boy, but then I could see all the people working on film and cutting film. It was just incredible, and worked on some really exciting projects. Um, but yeah, and that career went really well, and got in the Guinness Book of Records, with a team that we worked on Toshiba, for a commercial, which is a lot of fun. Worked with some amazing clients, on big global campaigns. Um, Even did a climate change campaign for the Central Office of Information for the government, which was if we could see the emissions that we're creating, we'd do something about it. So we had lots of colourful gas coming out of the back of cars and out of chimney stacks and aeroplanes, and the sky was filling up with all this kind of rainbow-coloured kind of gas. And it's like, wow, this is really horrendous. We got to do something about it. It's very pretty, but not, not for the long term. And so, we don't see it, right, other than the indirect consequences of floods and famines and wildfires, right? But I guess my original inspiration to do something in this comes from my grandfather, who it must have really stuck with me because when I was a little boy, he said to me, Christophe, one day fossil fuels will run out. And he came from a place of knowledge because he was the chief scientist at the engineering company called John Lang, and he was developing alternative energy, it was called then, for 20 years. So he was doing wave power, supersonic wind tunnels, flywheel technology. I mean, he was 5 decades ahead of his time, extraordinary scientist. He said to me, if you look at an annual calendar, we've only got a few minutes left of fossil fuels. If you were to put it in an annual calendar, and I was like, wow. Of course, I was a little boy, that kind of stuck in my mind. But and I was actually born in 1973, which is, I'm showing my age. But that's the first. That's when the first oil crisis happened, 1973. And so he told me about that, and that was amazing. And he was an extraordinary scientist. And I guess that's the itch. But I never said, thought, well, I need to do something in renewables. But when I got through the advertising career, I did want to do something that's much more purpose driven. And I worked on that in some of those campaigns that I worked on in advertising. And also, I wanted to create something that isn't just about me, it's a product that can do good. Because when you're in a creative industry, you have to sell yourself, you are the product. But if you go into renewables, you can create something that actually has a positive impact, and the people we work with now is just extraordinary. It's amazing men and women in science and entrepreneurs and people who are so mission driven. It's hugely stimulating and humbling. It really is. So, so my grandfather was the original inspiration, and I feel wholly unqualified, not being a scientist or an engineer, qualified engineer, but I'm a budding one. I learned a lot about it over the last few years, and so that's how it all got going.
Well, I think you've given all of our listeners who identify as creatives a lot of hope because at the end of the day, it is more than engineering and science. You need all the people with all of the skills to come to the table and develop solutions that will ultimately get us to where we need to be into this net zero future. One final question, Christophe, what is Naked Energy focused on right now? You mentioned that the team is quite mission orientated, quite passionate. It's very clear in the way that you speak. So what is next for Naked Energy?
Yeah, well, there's so much going on. So last year we were very fortunate that we closed an exciting investment round into the business. So we took in two new investors, quite very exciting investors. One, the lead investor is a company called E.ON, the big German utility company. And they're very exciting because they want to decarbonize heat. That's one of their core strategies. So there's a really good synergy in terms of their mission. They themselves own a lot of assets that need to be decarbonized in terms of heat generating assets. And they've got a lot of customers, a lot of these sort of commercial and industrial customers that we mentioned before that are looking for affordable decarbonization technologies. And additionally, E.ON as well, their typical business model is to deliver the service of decarbonisation. So they supply the design, integration, engineering, the heat pumps, the batteries, the monitoring platforms. And so we can bundle our solution with their existing offerings. And so it's a really good route to market. And so E.ON is one aspect of the investment, and that's what we're really focused on at the moment as a business, is building our partnership with them. And we're just a teensy weensy little company, and you've got the giant of E.ON. They're in 16 countries, and so we've been hiring. We've built a really good team, sort of expanding our commercial and business development team to work really closely with E.ON to build out other partners as well. But E.ON are by far and away our biggest partner. So really how we can then scale with them. And we're looking at projects that are 10 times the size of any project we've done before, which is really exciting. So our technology is proven, but it's just about doing it at bigger scale, right? And bigger projects and repeating that. So really exciting projects happening with E.ON. We also got co-investment from Barclays through their Climate Ventures Fund, which is really exciting. Barclays have raised $500 million off their own balance sheet to invest in climate positive impact companies. And we're one of 20 companies that they've invested in. They're very proactive on our board. They're really good investors. They are introducing us to some of their corporate clients that are looking to decarbonize. So we're trying one building at a time, and through partners, we're trying to decarbonize businesses and communities, not just in the UK, but internationally. So we're hiring teams in Iberia, in the Netherlands, and Germany. So we're expanding and supporting our new partners in the US as well, to do some exciting projects there. So there's a lot going on, and it's a very exciting time at the moment.
Christophe, that is indeed very exciting, and we will certainly keep an eye on your progress as you strip off the layers and really get to the core of decarbonisation, which is, of course, Naked's mission. So thank you so much for joining me today and for sharing your mission and your journey.
Oh, it's a real pleasure, and thank you for having me on and raising the profile for solar thermal and reminding everyone about decarbonisation of heat and how important it is. So really enjoyed chatting with you. Thank you.
And to all of our listeners, thank you for joining us. Until next time. Thank you for listening to this episode of the Energy Transitions podcast, brought to you by Enlit and Friends. That's a wrap from me, Pamela Largue, and our producer, Kamo Motse. We hope you can join us next time. Visit enlit.world or subscribe for more episodes.